I am sure we all wonder about the behind the scenes of the production process of these mega transports that deliver cargo, connect cities, reunite long-lost relatives, and sources of getaway trips. They are massive in size, and their production too. It takes thousands of employees, thousands of hours, thousands of square foot, and sophisticated, robust machinery and technology to fulfill the production schedule. Starting off with the bus production. Bus manufacturers ensure uncompromised quality in construction of their products to ensure safety, efficiency, comfort, and optimum reliability. It all starts off with flat sheets of metal, which are bended, processed into lengthy rectangular bars of steel. Then they're sectioned to the required suitable working size. The steel bars are then married together by welding. The welding process is carried by robot labor and human labor. Precision at times can be a concern. At times, robots are deployed in welding stations where long hours of welding are incurred to avoid excess human fatigue, which can result in errors, hence compromisation of quality in work. The steel bars are married together to form the frame structure of the bus. The frame structure is welded in various stations, where each station is dedicated to a particular section of the structure. Then finally, all sections of the structure are brought together to form one frame structure. The flat sheets of metal are also dedicated to form the wheel arcs and the chassis of the bus. After this first stage of production, the finished work goes in immediately for a quality inspection conducted by an assigned dedicated employee. Quality inspection is the most critical stage during production because without quality, no work ethic is evident, which in overall reduces the integrity, reliability, and the company's reputation. Certain stages of the production line involve the use of overhead cables. At this stage, it is used to transport the finished monocoque for galvanization to enhance resistance to wear, rust, and improve strength and stiffness. Strength and stiffness of the body frame are two important quality measures because they contribute to comfort in unpleasant drive terrains. Meanwhile, when extra layers of coating are added onto the monocoque, sheet panels are being prepared to close up the monocoque to make almost a finished bus. After the sheet panels are being fitted, the product now heads its way into the spray booth. Robots are deployed to fulfill some layer of paint as well as skilled humans. The spray painting stage is succeeded by quality human inspection to inspect for any unevenness on the paint layer. If it feels and looks smooth, natural, and shiny, then it is good to go on to the next stage, which is wiring. On average, buses are wired with 3.72 miles of wiring. Then the rear and side windows are fitted, seats are installed, the dashboard fitting is succeeded by the windshield to aid convenient fitting, followed by other interior items. Wires are then connected to power up all areas that need to be powered up. Then, inspection is conducted to observe for any wiring fault. At this stage of production, the vehicle is a fully functioning vehicle, waiting for the very last, final integrated inspection to test how it would perform on the road. The bus is put in a rain simulation room. Road performance testing is also conducted at this final stage of inspection to gather data such as horsepower and acceleration. Now it is time to see how the final product functions like in reality. It is time to experience the benefit of the hard work invested in great working hours. Data acquired from the simulation room is compared to a real-life situation. It is invalidated or validated. Work accuracy and precision is tested. The bus goes on a mini tour around the outside of the factory and uneven road surfaces to test for comfort rides. The Airbus company, first established back in the 1960s. The Airbus 350 is constructed of more than 2.5 million components. It takes a sum of 1,800 professionals consisting of technicians, engineers, and designers to have an Airbus aircraft ready for flight. This latest model is built to operate up to a greater range at minimum fuel as compared to its predecessor. This is one of Europe's largest manufacturing projects. Airbus 350 is one of the most advanced aircraft in technology. It is very revolutionary in craftsmanship. At 1 p.m., the White Whale Beluga Fleet Delivery Aircraft arrives at the Airbus 350 production factory to deliver all components. It is the key player to the success of the production process. It is large, consisting of 104.99 feet long wings. It takes 1 hour to offload the cargo. That 1 hour is very significant and critical. If it is exceeded, then the entire production line is delayed. The Airbus community is huge and still manages to work in harmony. 4,500 suppliers, 12 facilities, all dedicated to achieve a sophisticated, well-built, reliable Airbus 350 aircraft. France, Spain, Germany, and Great Britain are dedicated to supplying the essential parts that make up the 350. The nose is built all the way from Saint-Nazaire, the west coast of France, the tail all the way from Hamburg, northern city of Germany, wings from Broughton in England and Bremen in the north of Germany, and the horizontal tail from Getafe, a city in Spain. Should inventory run short, not a problem at all. It only takes 3 hours for components to be delivered from anywhere around Europe to the Airbus factory. Delivery is also fulfilled by the Beluga fleet. It takes 7 stations to assemble the 350. 120 aircraft are built annually. Approximately 40 workers are deployed to work on the fuse sections of the fuselage in a parallel fashion to install the large components of the passenger cabin, such as washrooms. 6:30 in the morning every day, a collective of technicians consisting mostly of electricians gather for a brief session prior to the commencement of the production. They will be responsible for the building of the galley and rest compartments. Every operator performs a task according to instructions, and every task is double-checked for precision. The Airbus 350 can endure a trip of 20 hours long. At this stage of production, the fuselage is also well insulated and equipped with hydraulic, water, oxygen, and air conditioning systems. All wiring is under the ceiling. The 3 fuselage sections add up to 242.35 feet. The fuselage sections prior to conjoinment are aligned in 0.39-inch gaps. Joining them requires 40,000 fasteners. The body of the Airbus 350 is made up of 53% carbon fiber, and that makes it 40% lighter than aluminum. The use of carbon fiber on the body aids for more complex shapes to be formed. Aviation is also one of the automobile industries introducing the carbon technology for now and future use. The nose section is assembled of 1,000 parts from high tensile steel materials. After its assembly, the wheel's advancing and retraction is tested using a remote control, and the wheel should operate at speed as it would during approach. At this stage of production, the fuselage is partially assembled and ready to leave the hangar. The operator of the aircraft tractor then grabs the nose wheels to help push it out of the hangar. The cigar makes its way to the next station. The word cigar is used to describe the Saluche without wings. The next station accommodates a maximum of 4 cigars. This is the station where almost everything is installed: the wings, landing gear, tail assembly, and exterior parts, making the plane 90% complete before exit. The aircraft wings go for wind tunnel testing, and the design of the flap is designed with the intention to reduce vortex generation, hence optimizing lift efficiency. The vertical tail comes all the way from Schneider in Germany. This is the only component painted prior to installation due to its height. The Airbus company consists of a total of 23,000 workers. It operates 5 days a week for 2 shifts. The early shift workers go to lunch first, followed by the office staff. The 15 restaurants surrounding the factory produce 2.6 million meals a year. 13.5 tons of steak and 10.5 tons of salad are produced in the current process. After lunch, time for the assembly of the wings, landing gear, and tails. Floor to floor, wall lining, safety components, signals for cabin crew and passengers and overhead units, oxygen masks are also installed. Cabin functions are regulated by a central control unit. This ensures 20% higher air humidity, high cabin pressure, leaving the space environment feeling normally like Earth life. The Airlog Distribution Center is where all parts are ordered for the 3 Airbus aircraft models, namely the Economy, Business, and First Class. Deliveries are made on a daily basis, 7 days a week from morning to midnight. The Airbus 350 consists of 111.847 miles of cabling, which is carefully inspected after installation. The engines are powered up by Rolls-Royce, each being able to produce 374 kilonewtons of thrust, consisting of 22 titanium blades, 9.84 feet in diameter. The turbine costs $362 million. The entire 350 Airbus costs $373.56 million. The paint job done on the 350 Airbus consists of 5 coats of low organic volatile compound content of polyurethane paint, which is better for the environment and the employees. And it's a wrap. After 4.5 months, the Airbus 350 is at a point where it is ready for inspection by the customer and ready to spread its wings and fly. I am sure we have also wondered how our cruise liners are designed, scheduled for production, and produced. We have often asked ourselves, could it have been ordinary human beings like you and me involved in the production? And today, I reveal to you the mystery behind the production of one of our favorite rides. I will answer the questions: who builds cruise ships? How long does it take to build a cruise ship? Where are they built? What materials are they made from? Cruise liners are one of the mega transports that are not entirely built in-house due to the incurred requirements of highly sophisticated equipment, tools, and expertise. So due to that reason, cruise liner companies outsource the production of their product. Different compartments are built outside the factory assembly. Meyer Werft from Germany, STX Europe, Fincantieri in Italy are 3 major shipbuilders, responsibility for the world's biggest cruise ships. These shipbuilders, known as shipwrights, operate massive shipyards in coastal and riverside towns. The design process of the ship, with sophisticated design tools such as computer-aided design, takes about 1 year. The building of the cruise ship takes 1 year to 18 months, from laying the keel to final delivery. The enhanced production process is aided by modular cabins. Only 4 shipyards exist today that build cruise ships. The unmentioned 4th one is the Mitsubishi Company. Fincantieri in Italy delivered its first cruise ship back in 1990, and it is said to be the biggest ship manufacturer in Europe. The family-owned company in Meyer Werft, Germany, commenced building their cruise ships in the 1980s. It is said that their shipyard is located in an awkward location as a result. Their ship has to travel via a river leading its ship to the North Sea. The STX Europe, with a contradicting name due to it actually being based in South Korea, this shipyard was responsible for the construction of the Royal Caribbean's Oasis and Allure of the Seas. Lightweight materials such as aluminum and high-strength steel are used in order to keep the center of mass low, despite their size. The heavy components such as engines, propellers, fuel tanks are located on the lower part of the cruise ship, and weight is evenly distributed to ensure centered gravity. The use of lightweight materials does not only help to reduce fuel consumption and emissions, but to cope with the change of environment of the sea. Fiber-reinforced plastics and carbon fiber are now being considered since they can lessen the mass and bring down the center of gravity by reducing weight above the waterline. The flat-pack cabins are magnet-based. This allows for more storage and organization of luggage, and magnetism is central to how cruise ships are constructed. Cabins are constructed separately from the rest of the vessel. Every part of the cabinet is fitted at the outsourcer's factory, such as the plumbing and furniture. They are then transported to the shipyard, ready and complete, and fitted into the vessel with magnetic force. The hull initiates the whole construction of the ship. A hull is the frame structure of the ship, which includes the base and the sides. It is constructed on dry land. It involves ground crews and massive cranes to build the watertight hull. Water control systems, which are man-made dams, are part of the production. They allow the working crew to build the ship, both in and out of the water. This can simultaneously test the constructed hull for watertight structure and allow the engineers to work on the underwater sections of the ship. Approximately 14 steps are involved in building a cruise ship. Firstly, starting with the design, production scheduling, arrival of steel, prime coating of the steel to avoid corrosion, cutting of the steel, processing of the steel, preparation of panels of the hull, steel parts assembly, block assembly, pipes and equipment fitting in the blocks, joining of blocks. Then, the ship goes for a sea trial, where its real-life performance will be put to a test after all the long, tedious production. Finally, a naming and a delivery ceremony is held for the cruise ship. Been a pleasure. Hope you enjoyed. Please do not forget to like, subscribe, and hit that notification bell so you do not miss out on anything right here on Auto Tech Talk.